Welcome students. Our today's topic is divisibility rules, or you can call it divisibility test or divisibility criteria. So let's start. Suppose if I give you a number, let's say 720, 720. So this is a number, a complete number, and if I ask you, can you find at least 10 numbers which will exactly divide this number 720, 720? Please listen my words carefully. I am saying exactly divide. It means that when you find any number, if it divide this number 720, 720, then remainder should be 0 and quotient should be whole number. Example, I will give one number as a hint, 2. So this 2 will divide this number and quotient will come 360, 360, right? So if I divide this 2 to this number, this quotient will come, and this quotient is whole number and remainder will be 0. So like that you need to find 10 more numbers. Can you do it? If you wish, you can pause this video and do your calculations. If you got your answer, correct answer, within a minute, then definitely you are thorough with this concept. But if you have taken more than 1 minute to get correct answer, then definitely you need to watch this video till end, because this video is for you and the concept which will be taught in this video is very useful for you. I will give the answer. The numbers are 2 I have given already, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and so on. So these are the numbers which will exactly divide this number 720, 720. How I got the answer so quickly? Because I know divisibility rules. You want to know those rules? Let's get started. In today's video, our 10-point agenda is like this. We will see what is divisibility, then we will see divisibility rule for 2, then for 3 and 9, then for 4 and 8, then for 5 and 10, then divisibility rule for 6, then for 7, then for 11, then 13, and at last we will see divisibility rule for any number. So this is our 10-point agenda. So what is divisibility? What do you think? Take an example. 64 divided by 2. How we are going to divide it? 2 3s are 6, 2 2s are 4. So 2 can divide 64 completely, right? Remainder is 0 and quotient is 32. So it means that 2 can exactly divide 64. correct. Take another example. If I divide same 64 by 5, 5 ones are 5, 1, 4, 5 twos are 10, 4. Further I cannot do it, right, because remainder is 4, there is no number here. But we can solve it further, right? We have learned those things. How? 64 divided by 5, 12 is there. So how we are going to solve it further? We can take 0 here. If I take 0 here, then I have to put decimal here. So 5 8s are 40. Now remainder came 0, but the quotient came in decimal or fraction, right? There is a difference between all three divisions. All three are divisions, right? This is also a division, this is also a division, this is also a division, but this one is exact division. Why exact division? Because remainder is 0 and quotient is whole number. Here remainder is 0, but quotient is not whole number, it's a decimal, and here remainder is 4. So can I say that this 2 exactly divide 64? Yes, I can say that. Can I also say that this 2 has ability to divide this 64 exactly, right? I can say that. So 2 has ability to divide 64 exactly. Here in terms of 5 don't have ability to divide 64 exactly, right, but 2 has. So this ability to divide exactly is nothing but divisibility. So can I say that 64 is divisible by 2? Yes, I can say that, because 2 is dividing 64 and remainder is 0 and quotient is whole number. This is called divisibility, ability to divide exactly. So 2 has ability to divide exactly for number 64, right? Got it? Divisibility rule for 2. So if in any number, if last digit is even means 0, 2, 4, 6, 8, there is a infinity even numbers, but we are interested in single digit even number. So these are the 5 numbers. So if last digit is even, then that number is divisible by 2. We will take an example. We have seen 64, right? In 64, last digit is, this is digit, right? This is one digit, this is, and this is another digit, and this is a number. So last digit is 4, which is even, so hence it is divisible by 2. In our question, 720 is the number given, right? Here also last digit is 0, hence this number is divisible by 2. Divisibility rule for 3. add all the digits in a number. Take an example, 81. You have to add all the digits in this 81. So 8 plus 1 is equal to 9. If this addition is divisible by 3, then this 81 is divisible by 3. Yes, 9 is divisible by 3 because in table of 3, 3 3s are 9 is there. Hence 81 is divisible by 3. We have seen 64, right? So can you check that 64 is divisible by 3 or not? 6 plus 4 is equal to 10, and this 10 is not divisible by 3. That's why 64 is not divisible by 3. These are the small numbers, but the problem come in big numbers. Like if I give you 343, right? This is the number. So you have to add 3 plus 4 plus 3. So you have to add digits, right? 3 plus 4, 7, 7 plus 3 is equal to 10. And again 10 is not divisible by 3. Hence 343 is not divisible by 3. If I take our example 720, 720, here if I add digits 7 plus 2 plus 0 plus 7 plus 2 plus 0, it would be 9 plus 9, 18, and 18 is divisible by 3. Hence this 720, 720 number is divisible by 3, right? One more trick I will tell you. If a number is really long and addition came a bigger number, then what you will do? Suppose number is 1, 2, 3, 4, 5, 6, 7, 8, 9. This one big, right? This is one number, right? These are not a separate digits, and I have to check this number is divisible by 3 or not. How I will do? I will add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, right? So 9 plus 8, 17, 17 plus 7, 24, 24 plus 6, 30, 30 plus 5, 35, 35 plus 4, 39 plus 3, 42, right? 44, 45. So total came 45. So 45 is divisible by 3. If you are not sure that 45 is divisible by 3 or not, you can add this number, these two digits again. So 4 plus 5 is equal to 9. So 9, I think you can easily identify whether it is divisible by 3 or not. Yes, 9 is divisible by 3. Hence this complete number is divisible by 3. See how it helps in bigger number, right? Divisibility rule for 9. So it is similar to divisibility rule for 3, right? So you have to add all the digits in a number, and if the addition is divisible by 9, then that number is divisible by 9. So we have taken an example 81, right? So in 81, 8 plus 1 is equal to 9. So 9 is divisible by 9, hence 81 is divisible by 9. Again we have taken an example of 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So here we have seen that addition of all those numbers is 45. We have seen that, and 45 is divisible by 9. 9 5s are 45. If you are not sure, again you can add 4 plus 5 is equal to 9, and of course 9 is divisible by 9. So this number 1 2 3 4 5 6 7 8 9, this complete number, these are not separate digits, this is a complete number, one number. So this number is divisible by 9. So coming back to our example, 720, 720. If I add this number 7 plus 2 plus 0 plus 7 plus 2 plus 0, we have seen that the total came 18, and 18 is divisible by 9. So this number 720, 720 is divisible by 9. Divisibility rule for 4. If a number formed by last two digits is divisible by 4, then that number is divisible by 4. That is the rule. Take an example. This number 516. The number formed by last two digits, 1 and 6 are the last two digits of a number, is the 16. So 16 is divisible by 4? Yes, 4 4s are 16. Hence 516 is divisible by 4. That's the rule. Here last two digits are 23. This is the number formed by last two digits. 23 is divisible by 4? No. 23 is not divisible by 4 because 4 6 are 24. It is 23. So 723 is not divisible by 4. Similarly, our number 89 are the last two digits. The number form is 89, and 89 is divisible by 4? No, it is not divisible by 4 because 4 2s are 8, then 4 2s are 8, 1 will be remainder. Hence this number is not divisible by 4. Our number which is in question, right, 720 and 720. Here the last two digits are 2 and 0, and the number form is 20. So 20 is divisible by 4. Hence this 720 number is divisible by 4. Divisibility test for 8. It is similar to divisibility test for 4. Just instead of last two digits, you have to take last three digits. So number formed by last three digit, if that number is divisible by 8, then the number is divisible by 8. Take an example like 5632. So 5632 is the number. Last three digits are 632, and the number form is 632. If I divide 632 by 8, then 79 is the quotient, remainder is 0. So I can exactly divide the 632. So 632 is divisible by 8. Hence this 5632 number is divisible by 8. Our example 1 2 3 4 5 6 7 8 9. Last three digits are 789 and number is 789. If I divide this 789 by 8, 98 is the quotient and remainder is 5. So 789 is not divisible by 8. Hence this number is not divisible by 8. So now our number 720. So a number formed by last three digits 720. If 720 is divisible by 8, yes, because if I divide 720, 8 9s are 72, 0 0 and 0, 90 will come. So 720 is divisible by 8, hence this bigger number 720 is divisible by 8. Divisibility rule for 5. So if last digit is 5 or 0, then that number is divisible by 5. It is very simple. So here last digit is 0, here last digit is 5, here last digit is 5. So all three numbers are divisible by 5. Now our number 1, 2, 3, 4, 5, 6, 7, 8, 9, this bigger number, last digit is 9. So it is not 0, it is not 5. So this number is not divisible by 5. Now our magic number 720, 720. Here the last number is 0. Sorry, last digit is 0. So 0 is there. So this number is divisible by 5. Divisibility rule for 6. So we have seen divisibility rule for 2 and 3. So for 6, combination of these two, because the prime factor of 6 are 2 and 3, because 2 3s are 6. 2 and 3 are prime factors of 6. So if a number satisfied a test for 2 and 3, then that number is divisible by 6. Take an example, 54. Let's check for 2, last digit should be even. So 4 is even, right? So this 54 is divisible by 2. Then for 3, we have to add this. 5 plus 4 is 9, and 9 is divisible by 3. Hence this 54 is divisible by 3. So this 54 is divisible by 2 as well as 3. Hence this 54 is divisible by 6, right? Similarly 120, last digit is 0, which is even. So 2, test for 2 is satisfied. 1 plus 2 is 3, and 3 is divisible by 3. So test for 3 also satisfied, so it is divisible by 6. Our number 1, 2, 3, 4, 5, 6, 7, 8, 9, last digit is 9, which is not even, right? So this number is not divisible by 2. So one test, which is 2, is failed. Hence this number is not divisible by 6. Our magic number 720, 720, last digit is 0, which is even. Hence it is divisible by 2. And we know that addition of this number, all digits, sorry, addition of all these digits is 18. 18, and 18 is divisible by 3. We have seen that this number is divisible by 3. Hence this number is divisible by 6 as well, because 2 and 3 tests are satisfied here. This is about divisibility rule of 6. Divisibility rule for 7. So number formed by rest of the digits minus 2 into last digit is equal to answer. And if answer is 0 or divisible by 7, then that number is divisible by 7. So what is the meaning of this sentence? Let's see. Last digit is 3, right? And if I leave this last digit aside, so what will be the number formed? 34. So what I have to do? 34, I have to take 34 minus last digit 3 into 2. So how much would be? 34 minus 6, which will be 28. And 28 is divisible by 7. 7 for the 28. Hence 343 is divisible by 7. So number formed by rest of the digits means if you have to leave this 3 last digit, you have to leave last digit, and number formed by rest of the digit is 34, and you have to subtract twice of this last digit from 34. So it would be 28, and 28 is divisible by 7. hence this 343 is divisible by 7. Similarly for 96, if I leave this 6 aside and 19 is the number and I had to subtract twice of this last digit, 6 into 2, how much it would be? 19 minus 12 is equal to 7, and 7 is divisible by 7, hence 196 is divisible by 7. Our magic number 720, 720. Now here last number is 0, right, and leaving that last number, the number form is 72072. So I have to subtract 72072 minus 0 into 2. It would be the same number, right? 72072. Now from this 72072, again I will multiply this 2 by 2 and subtract from rest of the number 7207. So minus 4, it would be 7203. So what we got? 7203. Again I will multiply this 3 by 2 and subtract from this number 720. So 3 to the 6, so I will subtract 6 from 720. So it would be 4, 1, 714. Again I will multiply this 4 by 2, so it would be 8 and subtract from 71. It would be 11 minus 8, 3, 63, and this 63 is divisible by 7. 7 9s are 63, right? So hence 720 is divisible by 7, right? So you have to repeat that process. So this number will be shortest one. First 720720, then it will be 72072, then 7207, 720, then 72, and then you will get the answer. This rule is little bit tricky. So if you are preparing for Olympiads or IIT-JEE or NEET, in those exams, this rule is important. This rule is used in mathematics, in physics, in chemistry as well, wherever arithmetic or numbers are there. This rule is useful for those students who are preparing competitive exams, right? So state level, center level competitive exams. So for them also this rule is very useful. So very important rule. Divisibility test for 10. This is very simple. If last digit is 0, then that number is divisible by 10. In 100, last number is 0. In 320, last number is 0. In our example 1 2 3 4 5 6 7 8 9, here last number is not 0, it is 9. So this number is not divisible by 10. Our magic number 720, last number is 0, hence it is divisible by 10. Divisibility rule for 11. Sum of digits at odd places minus sum of digit at even places equal to 0 or divisible by 11, then that number is divisible by 11. What does it mean? So take an example 5016. So this last digit is the first place, right? We call it as one place, right, in arithmetic. This second last digit, that is 1, is second place. and this one is third place and this is fourth place. So 1 is odd, we know that, 2 is even, 3 is odd, 4 is even. So which one is the number or digit in odd place? 6. So you have to add 6 plus 0, because these are the numbers or digits at odd places. This is first place, this is third place, right? First, second, third, fourth. These 4 places are there. So 6 plus 0 you have to add 6 plus 0. Then you have to subtract addition of or sum of even places. Even, which one is even? 1 and 5. 1 is even place because it's second place. Though the digit is 1, but the place is 2, second place, right? Have you got it? This is the second place. This is first place, this is second place, third place and fourth place. Second place means 2, 2 means even. So this is even place. So this 10th place, this is called 10th place in arithmetic, right? We know that. This is 1 place, this is 10th place, this is 100th place, this is 1000th place. So this second place, which is even, 1 plus 5, this is fourth place. So you have to add digits at even place as well. 5 plus 1 and do the subtraction. 6 plus 0, 6 minus 6 is equal to 0. Hence this 5016 is divisible by 11. So if your answer is 0 or divisible by 11, then that number is divisible by 11. Sum of digits at odd places minus sum of digits at even places is equal to 0 or divisible by 11, then that number is divisible by 11. Take an example 9251. Here if I add odd place digits 1 plus 2 minus even place digit 9 plus 5. So 3 minus 9 plus 5, 14 is equal to minus 11, right? Do not get confused with this negative sign because this is meaningless for us. So 11 has come, right? So 11 is divisible by 11, hence this 9251 is divisible by 11. Our magic number, which are the odd place digits, 0 plus 7, this plus 2 minus even place digits 2, 0 and 7, 2 plus 0 plus 7. So 9 minus 9 is equal to 0, hence answer is 0. So this number is divisible by 11. So what is our test? It should be 0 or divisible by 11. So 720 is divisible by 11. Got it? This is little bit trickier one, but once you do practice you will thorough with that. So can you solve for this number 1 2 3 4 5 6 7 8 9? Just add odd place digits, that is 9 plus 7 plus 5 plus 3 plus 1, get a sum of that and subtract even place digits like 8 plus 6 plus 4 plus 2 and see if it is coming 0 or multiple of 11, right? Then this number is divisible by 11. If not, then it is not. Divisibility rule for 13. Multiply last digit by 4. Add in balanced number. And what your answer, if that answer is multiple of 13, then that number is divisible by 13. What does it mean? Take an example. 6435 is the number and we need to check that whether this number is divisible by 13 or not. So here the magic number is 4. Just remember this 4 number in divisibility rule for 13. So last digit is 5. You have to multiply this 5 by 4, that is 20, and you have to add 20 in this number, leaving that last digit, whatever number is formed 643, you have to add this 20 here. So 663, right? Again last digit is 3, you have to multiply it by 4, that is 12. So you have to add 12 here. 6 plus 2, 8, 7. So can you determine that 78 is multiple of 13 or 78 is divisible by 13? Yes, in the table of 13, 6 are 78, right? Hence 6435 is divisible by 13. Similarly, we can find out for this bigger number 59384. So if I multiply this 0 by 4, 0 will come and we have to add this 0 here, 72072. Again this 2 by 4, so add 8, 2 4s are 8, 15, 2 7. Again 5 4s are 20, 1 4 7. Again 1 4s are 4, 78. So my answer is 78, and 78 is divisible by 13. 13 6 are 78. Hence 720720 is divisible by 13. Divisibility test for any number. So till now you have learned divisibility rule or test or criteria for 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 13. So beyond that as well, you can derive your own divisibility rule, right? Suppose for 17, 19 or 23, if you want to derive your own formula for divisibility, then you can do that. How? You need to use oscillator technique, a technique called oscillator technique. So what is that? In that we normally use polynomial. So if you are from 8th standard and above or 8th class and above, then you must have heard this word polynomial, right? So by using polynomial, you need to find out roots of 8 and derive formula for any number. If you want to know more about it, then please contact us or you write in comment below so that I can provide guidance for that. Okay, but 2 to 13, these rules are enough for solving any kind of sums in any competitive exam. So let's practice those techniques or those rules, and you will be master of it, and definitely you will solve any sum in 30 seconds only by using those rules. So these rules are very important. These are used in all sort of arithmetic and mathematics sums. Thank you for watching this video. If you like my teaching, then please like, subscribe and share this video so that maximum people can get benefit from this video. Thank you for the watching. See you later.